okay, we can recall this restriction here, okay, where we put a condition here. The combination, okay, for the weight and the number of items cannot be more than or cannot be exceed the total weight. So for example here, if let's say, okay, the total weight is 2, so basically the combination between the number of units, okay, times the weight of the unit cannot exceed 2. So in this case, since for item number 3, the weight is 1. Okay, item number 3, the weight is 1. So that's why we just have to, for example, for M3 equals to 0, so 0 times 1 equals to 0. Okay, if now M3 equals to 1, okay, so 1 times 1 is 1, and this one is less than 2. So we can have the value here. Okay, so so the value here is 14 M3. So 14 times M3 equals to 1. So 14 times 1 is 14. Now, if M3 equals to 2, so first you have to check this constraint first. So W3 equals to 1. So 1 times 2 is 2. And 2 is still less than equals to 2. So that's why we can have the value here. Okay, so what is the value? You take 2 times 14. So that's why we got 28. Now, when M3 equals to 3, so when we check for this constraint, okay, so it will be 1 times 3 equals to 3. And this 3 is actually greater than 2. So in this case, we can say that this is infeasible. So 3 onwards will be infeasible. Why? Because at this state, we only, the total weight is only 2. Okay, but now, if we choose the number of units equals to 3, so 3 times 1 is already 3. So 3 is already exceed the total weight that we allocate. So in this case, it is infeasible. So first step, okay, for this table, you should find, or you should try to find all these infeasible solution first, and then we can exclude, okay, from the calculation. Now you have to find all these feasible solution for x3. Okay, so for example, when x3 equals to 0, so the value is 0 times 14. Okay, when m3 equals to 0, so 0 times 14 is 0. So that's why you have 0 here. Okay, for let's say x3 equals to 4. Okay, so when m3 equals to 0, so 0 times 14 is 0. Okay, when m3 equals to 1, 14 times 1 is 14. When m3 equals to 2, 14 times 2 is 28. When m3 equals to 3, 14 times 3 is 42. And when m3 equals to 4, 14 times 4 is 56. So you have to do all this, okay, in order to find the feasible solution. Then for the optimum solution, so since for this example, we want to find the maximum value because we want to maximize the return. So maximize the return means that for every solution here, okay, for example, for x3 equals to 0, but in this case, you have no option. Okay, this is the only value that we have, 0. So the value is 0, and it comes from 0. When x3 equals to 1, so you have to compare between 0 and 14. So maximum value is 14, and it comes from 1. Okay, here, because 14 comes from 1. Okay, so same goes to all the values. Okay, so you have to find the maximum value here. Okay, the optimal solution here, and you have to decide where are they are coming from. Okay, the alternative that they are coming from. Now for stage 2. Okay, so first thing, the total weight will be the same. Okay, it's either 0 up until 4. But now for the alternative, you have to calculate again. So for the alternative, remember the total capacity is 4 ton and the weight for every item number 2, remember stage 2 is for item number 2. Okay, the weight for every item number 2 is 3. So 4 divided by 3, you have 1 point something. Okay, but because this is integer, because it refers to the number of items, so you got 4 divided by 3, 1 point something. So in this case, you can say that M2 equals to 0 and 1. It cannot be 2. Because if it is 2, if you decide to take 2 items, okay, so 2 times 3 is already 6. Okay, which is already greater than the maximum capacity, which is only 4. So in this case, you can decide, okay, in our decision, you can decide whether you can take 0 units of item 2 or 1 unit of item 2. So that's why we have M2 equals to 0 and M2 equals to 1. Now, the equation here is a bit different. If in stage 3, you only have to take the returns, okay, the return for item number 3 and times with the number of units for item number 3. But remember, we have to we must have a relationship, okay, between previous stage and this stage. Okay, and from here, xi minus xi plus 1 equals to wimi. This is actually, this one represents the weight used at stage I. And we can manipulate this equation, okay, for the backward equation. So we have xi plus 1 equals to xi minus wimi. Okay, so then from here we have this one. Okay, so now we are at stage 2. Okay, so I equals to 2. So when x equals to 3, so it will be f3, okay, equals to x2 minus 3 times m2. 3 here is the weight for item number 2. So that's how we come out with this equation. At the same time, don't forget, we will still apply the constraint of wimi is less than equal x2. So first we have to find or identify which one is infeasible and which one is feasible. So in this case, okay, so for stage 2 is for item number 2 and the weight for item number 2 is 3. So first thing you have to do is you have to find the value of this combination. That means 3 times 0. So 3 times 0 is 0. So basically for 0, 0 is less than all these values. So we can have the feasible solution for all this. So no problem. But when M2 equals to 1, okay, so it will be 3 times 1, which is equals to 3. And this 3, okay, so that means we cannot find the solution for x2 equals to 0, equals to 1, and equals to 2. Okay, because 0, 1, and 2 is less than 3. So in this case, when m2 equals to 1, we can only find a feasible solution when x2 equals to 3 and when x2 equals to 4. Then the values here can be obtained using this equation. Okay, so for example, if let's say for x2 equals to 4, okay, for m2 equals to 0, so it will be 47 times 0. Okay, so you got 0 and plus f3, okay, x2 equals to 4, so 4 minus 3 times 0. So in this case, we have 0 plus f3 of, okay, 3 times 0 is 0, so 4 minus 0 is 4. And if we refer back to our previous stage, okay, stage 3, so that means f3 of 4 equals to 56. Okay, So f3 of 4 means that f3 of x3 equals to 4. So when x3 equals to 4, the value is 56. So that's why we add 56 here. So 0 plus 56 is 56. Same goes here when m2 equals to 1. So 47 times 1 plus f3 of, now x2 equals to 4, 4 minus 3 times m1, m2 is 1. So we have 47 plus f3 of 1. So here from previous iteration, f3 of 1 equals to 14. Okay, so that's why here it will be 47 plus 14 and the value is 61. So you can do this for all these feasible solution. Okay, and for the optimal solution, again, since we want to find the maximum value, so the first one, when x2 equals to 0, you have no option. Okay, you compare between 0 and the infeasible solution, so the value is 0. Then when x2 equals to 1, you have to compare between 14 and the infeasible solution, so we take 14. When x2 equals to 2, compare between 28 and infeasible, so we have 28. So all these come from 0, okay, when m2 equals to 0. Then when x2 equals to 3, you have to compare between 42 and 47, and the maximum value is 47 and it comes from 1, okay, and m2 equals to 1. Okay, means that we choose 1 unit of item 2. Okay, when x2 equals to 4, so you have to compare between 56 and 61. So maximum value is 61 and 61 come from 1. Means that 1 unit of item number 2. Then for stage 1, okay, again the state should be the same. Okay, the total weight is either 0, 1, 2, 3 or 4. And then for the alternative, remember we have 4 as the total, and you have to divide by 2. 2 here is the weight per item 1. Okay, so 4 divided by 2 is 2. So now for the alternative, you can choose, okay, the number of unit can be 0, 1 or 2. Okay, you have m1 equal to 0, m1 equals to 2, and m1 equals to 1, and m1 equals to 2. And the equation here is the same like the one that we obtained in stage 2. Okay, where 31 here is the written for item number 1, and this part is the one like I mentioned before in stage 2. Don't forget our extra condition. Okay, W1 M1 should be less than X1. Okay, the total weight.